Hello. So in our last video, we looked at what a system of equations is. In this video, we're going to look at how to solve them, not by guessing and checking. What happens if I don't give you choices? What happens if you have to do it yourself? There are three methods: graphing, substitution, and elimination. The first one that you will probably learn in class is graphing, and the reason why is this draws a very clear connection between systems of equations and what you learned in the previous chapters, which was writing and graphing linear equations. So just to review, if we have a linear equation and we take another linear equation, we partner them together, we call that a system. And you can make 3 or 4 or 5. It doesn't have to be limited to 2. But we usually will stick with 2 in high school math. You partner them up. That's a system. The solution to a system is, remember, the x and y that works for both equations. And there are only 3 options: one solution, infinite solutions, or no solutions at all. Remember, we have 3 specific terminologies for each of those cases. I have added from our last video the graphs. What does the graph look like for each of those particular situations? The first one, consistent and independent. One solution. You have 2 lines, 2 linear equations. You graph them, they cross at a single point. So right here is your solution. Infinite solutions, called consistent and dependent, mean they are the same line. So there's only one line there. And again, infinite solutions is very easy to recognize because when you go to graph it, most of the time you'd put in slope-intercept form and you would see that they were identical. I can't speak for all math teachers, but I will tell you on quizzes and tests, I almost never put infinite in the graphing section because it's just too obvious. The last one, no solution, called inconsistent, means that the lines don't share any points. There is no x and y that works for both equations. They never intersect. As you may remember, those are called parallel lines, and the system is said to have no solution. In that case, the symbol for parallel looks a lot like, well, parallel lines. And again, that one I will tell you, you have to be careful with. Now, again, I can't speak for all teachers, but I will tell you that if I am quizzing or testing my class, I will provide a graph, and if there is a solution, it will be found in the graph that I've provided, whatever that span of points is. When you are doing homework or something where you have to draw your own graph, you have to be very careful to make sure that those lines actually don't cross, and not just that they don't cross in the part of the graph you've constructed. So when we get to, there is one no solution in this video. When we get there, I will give you another tool to recognize whether or not it's no solution, in addition to making your graph. All right. So the easiest system to graph is similar to the first system we saw in the last video. I give you one of the variables. I tell you the value of y is 3. Now remember, we are going to graph this. If you have a y equals, that is a horizontal line. Why? Because all I'm telling you and all I care about is that y is 3. I don't really care what x is. X could be anything. X could be everything. X could be nothing. I don't care. All I care about is the collection of ordered pairs where y is equal to 3. That's a horizontal line. We'll do the other one in gold. I went to Loyola University Chicago. If we even have a season this year, 2021 NCAA tournament champions. So, well, I'm just saying. So we'll use red and gold. So we have a slope and a y-intercept in this one. So we will go to 4 as our y-intercept, up 1 over 1 for our slope. And I'm going to use the ruler, but remember that you can also go down 1 and 1 to the left, since we know the graphs are going to cross on the left-hand side versus, off at the top right. I'm going to draw my graph. Ruler can go away now. Okay. And I'm looking for the place where those lines cross, which is right here whoops, not right there, right there. The red one crosses the gold one at the point -1, +3. Now, I'm going to show you how to check it, but remember, this does fit with what we were given because we were told that the y coordinate has to be 3. Let's check. Y equals x plus 4. Again, I'm not checking the other one because I already know what it is. 3 is y, -1 is x. 3 equals -1 plus 4 is 3. That checks out. This is the solution to the system. Another one. This one's a little bit more difficult because, as you can see here, there is not a nice y equals number. Okay, so we gotta graph both of them. We'll do the first one in red. I'll bring my ruler back. So we've got +2 for our intercept, -3/4, so we're going to go down 3, 1, 2, 3, and over 1, 2, 3, 4 to the right. And I'm going to put in my line, if I can make the ruler cooperate here. And if you have the option to use color, I would highly suggest doing it just because it makes it a lot easier to identify which line is which in case you make a mistake. -3 for our y-intercept, and we're going to go up 1 and over 2. 1, 1, 2. I'm going to do it again, up 1, 1, 2. Now I see the solution there because I colored in the same point twice, but let's just graph it. Actually, that's the right slope. And we've got a solution at the point 4 for x, -1 for y. And you could check that. I'm not going to do that in this video. So again, draw the lines, see where they cross. I'm going to do this one. If you want to pause and do this yourself, you certainly may, though I understand if you don't have a graph in front of you, it might be a little bit difficult. For this one, we're going to start at -2. We're going to go down 1 and over 1 for the slope. Now, some of you may be thinking, there is a downfall to graphing with to solving a system with graphing. We'll see if we'll see it here. We start at 4 for the second one. 1, 2, 3, 4, 5, 6, 7, and over 1 to the right. We are going to see it here. So again, just to make sure we've done this right, we had y-intercept at 4. We went down 7. 1, 2, 3, 4, 5, 6, 7. And we went 1 to the right. Oh, we're not going to see it here. Too bad. We do have an easily identifiable solution here at +1, -3. Now, I'm going to draw another line that has nothing to do with the ones that have been given here. Just do this. Actually, let me just do the one that I made the mistake. So we'll say the blue one is y equals actually, that would be +7x plus 4. So this is the blue line. And again, I'm just making this up. The solution to the system is given as still what I had written. Okay, now I want to talk about this point before we move on to the one no solution in this video. The reason I bring this up, so see the gold and the yellow, or the gold and the red. Gold and yellow are the same color. Those two crossed at an easily identifiable point. They were at the corner of one of those squares in the graph. I was able to say the x was 1 and the y was -3. The blue and the red have not crossed at a nice point. I don't know what that is. What is that? -1/2, 1/3? I don't know what that is. This is some kind of fraction. And I don't like fractions on graphs. Why don't I like fractions on graphs? Because it's not easy for me to tell what they are. So graphing is a good method to solve a system with. In very limited cases, when you're told to, for example, or if you have access to a computer that can construct graphs based on the information you give it. Very hard to freehand a graph to find the solution to a system because of the fact that we don't always get nice integer coordinates. So just be aware of that. You never want to guess. Okay, you never want to just say, oh, if it's in a space, it must be 0.5 or something like that. That's not a thing. So again, graphing is nice. Graphing is easy when it works. Sometimes it can be very complicated. So just be aware of that. That's why we have two other methods. The last one, as promised, is a no solution. You may already know why. So I'm going to take the first one, -4. The slope is 5/3. So I'm going to go up 5, 1, 2, 3, 4, 5, and over 3, 1, 2, 3. And I'm going to draw my line. And just for purposes of explanation, I'm going to exaggerate this way, way, way outside the graph that I've given. Again, I'm just exaggerating this for explanation purposes. 5/3 x minus 2, -2, up 5, 1, 2, 3, 4, 5, over 3, 1, 2, 3. And I'm going to do the same thing again. Now, because of the numbers in these problems, they are very close together, but I want you to notice these two lines will never cross. I don't care how far down below the screen I go, I don't care how high up at the right I go, they are never going to cross. This is an example of a system with no solution. These are parallel, remember that symbol, lines, which mean no solution. Now I told you, if you're freehanding this, let's say you drew a graph that was small, or maybe you got the scale mixed up, or maybe you're like me and can't draw straight lines without a ruler and you didn't use one. So you don't know, maybe they look like they cross when they shouldn't, or they don't cross when they should, or maybe, like I said, your graph was too small and they crossed at like 10, -5 or something way outside of your graph. There is a very easy way to tell, you may remember this from the previous chapter, if you have a no solution. Parallel lines have the same slope. So parallel, we have the same slope. So if you put both of your equations in slope-intercept or point-slope form, these are slope-intercept obviously, and you see that the slopes are the same, those are parallel lines and they do not have a solution, and there you go. There is one other thing. Like I said, infinite solutions is the same exact line. So for parallel lines, we should have the same slope and different or not equal y-intercepts. So if you notice the slopes are the same, just glance at the y-intercept and make sure that they're different. Make sure they're not two of the same line. Okay. They're same slope and same y-intercept. They're the same line, which is your infinite solutions. All right. Thanks for watching this one, and tune in to the ones on substitution, elimination.